Now we're going to get a deeper look into the chemistry part of an atom. You know what an atom is, you know what makes it up. Now we're going to talk about the various levels of the atom. So if you have a group of atoms of the same kind, making it a pure substance, that is called an element. So the periodic table, this chart right here that's pictured, those are all of the elements that we currently know of today. Now, sometimes elements like to join with other elements to create a more complicated molecule. That is what we call a compound. A compound is formed whenever two or more elements chemically join together in definite proportions, like water. Water, as you can see from the picture, is made up of 2 hydrogen atoms and 1 oxygen atom. Now, to make it even more complicated, sometimes the particles inside the atoms, the protons, the neutrons, or the electrons, like to move and sneak up on us. Whenever that happens, obviously a different substance is created. So let's start by talking about an isotope. The neutrons like to move here. Some like to disappear altogether off the face of the earth, or extra neutrons may be added into the atom. Anytime there's a change in the number of neutrons, we refer to that substance as being an isotope. So let's take a quick peek at this picture. Carbon is a special atom that can form an isotope. The normal carbon that's listed on the periodic table is listed to my left. This one right here. This is the normal carbon. Notice how many protons, how many neutrons, and how many electrons it has. It's also nicknamed carbon-12. So carbon-12 has 6 protons, 6 neutrons, and 6 electrons. The isotope carbon, on the other hand, is pictured on the right side. It's nicknamed carbon-14 because of the change in the number of neutrons. It still has 6 protons, it still has 6 electrons, but now there's 8 neutrons, so we have to accommodate that difference. Now the second type of particle in the atom that really likes to move is also the electron. Remember, the electron never stays still. It's constantly moving because it's super excited. So sometimes electrons jump from one atom to the next. And anytime this happens, a new substance called an ion is created. So whenever you get or lose an electron, it's either known as a positive ion or a negative ion. If a substance gets an electron, it's known as a negative ion because you are increasing the negative charges. If it loses an electron, it's a positive ion because you're decreasing the negative charges. Here's a way to remember that electrons are involved in making an ion. Think of the word election. Elect is short for electrons, and then the remaining 3 letters spell out ion. Okay, so here's a little visual of how ions are formed. We're taking a look at the chlorine atom as well as the sodium atom. The chlorine atom normally has 17 protons and 17 electrons. Now, because the chlorine atom gets an extra electron, it becomes a negative chlorine ion. The bottom diagram is our ion. Now it has 18 electrons instead of 17. The sodium atom normally has 11 protons and 11 electrons, but one of the sodium atoms likes to jump, so now the sodium ion has only 10 electrons. So because it has lost an electron, it's known as a positive ion. Now, when atoms join together to form compounds, the electrons have to somehow be connected to each other in between the two atoms. So we have what's known as a chemical bond. A chemical bond is always a union or a joining between the electrons of the atoms, typically because the electrons are on the outside and they're the easiest particle to get a hold of. So there's two types of chemical bonds, ionic and covalent. In the ionic bond, ions are forming, hence the name ionic, ions. So electrons are jumping and they're forming a positive ion and a negative ion. Well, positive charges and negative charges are automatically attracted to each other. The main idea behind the ionic bond is that opposites attract. So the positive ion and the negative ion join together, creating a compound. And now the electrons are joined together in that ionic bond. For example, sodium chloride, NaCl, also known as table salt. And here it is. Sodium, Na, and chlorine, Cl, join together because this electron, the red electron at the top, is being transferred over to the chlorine. So the sodium loses an electron. It is a positive ion. The chlorine is gaining an electron. It is a negative ion. Positive, negative are attracted, and hence your ionic bond is formed, forming your new compound NaCl. Now, instead of moving, sometimes electrons are shared. Whenever electrons are shared, this is called the covalent bond. Electrons always get shared in a pair. So if one pair of electrons are being shared, that's known as a single bond. If 4 electrons are being shared, that's a double bond. And if 6 electrons are being shared, that's known as a triple bond. But as long as those 2 electrons are being shared in between elements, you are forming a compound. Alright, so here's our covalent bond. You start with 2 chlorine atoms. And if you look at the chlorine atoms, there's one electron that is not a part of a pair. Electrons, they always like to travel in pairs, so they're going to do their best to try to find another electron so they can travel by twos. So each chlorine atom has a lone electron. They join together, forming their pair, and now they're shared in between the 2 chlorine atoms. There is your covalent bond. Now there's 2 types of covalent bonds, nonpolar covalent and polar covalent. And the way to remember this is imagine that you're stranded in an Arctic region with many polar bears. And the only thing that you have to survive off for eating is fish. Do you think that the polar bear would share the fish with you equally? I don't think so. They will share, but obviously the polar bear will get more of the share. So the polar covalent bond, the atoms are being shared with you, however, they are not equal. The polar bear may have 4 fish, and you may have 2. In the nonpolar covalent, the fish or the atoms are shared equally. So the polar bear has 3 fish, and you also have 3 fish.